Hello, my dear viewers. We are now going through a very hard times due to this pandemic. That's why when I talk to my friends, they said that the children now needs care. What all they are studying, they are stressed by the outside world situations. So you need to be more taking care of the children uh, which you are dealing with. So I'm first of all I am apologizing for the first videos which I have put is somewhat very short to the point. That means you must put that speed of YouTube to 0.75 or zero point 0.5 to listen to it carefully so that you would understand. But right now I think I should go in a very slow and steady pace so that to make you calm, very comfortable and very peaceful. So I will do the thing because my friends called on me because they need care to understand it better. So, so I apologize for you. Please like, share, subscribe my channel. The point is, before the earlier videos, regarding the Kirchhoff's law, the applications of Kirchhoff's laws, and any or entrance-oriented board examination, competitive examination questions, you all just put on the adjustment speed to 0.75 or 0.5 so that you could understand it better, because I have said every point in a shrinked manner, in a very concise manner, very precise. Brevity for brevity, I have made that because I do also know that the you all people's attention, no, you just can attend to 15 minutes, etc. 15 minutes. So if you tackle a question in 7 or 10 minutes, no, then you can take a rest. I have adopted in my academy, in my tuition class itself, students will be given a question, and after that a rest time is given so that they could take rest and deal with the next question. So it is possible for you with my videos, because you understand a question well or a group of questions well and take rest, because it will happen between it will be nearly 20 minutes only, so that you will strenuously understand that, or you would understand to the basic points, and then you can take rest. So I will now on take much more care in my videos so that to make you understand, because you all need care. So I love you. The thing is that what role I am dealing with the previous videos, please like, share and subscribe. Put that videos in a lesser speed and understand well. Make it a subject for group discussion if possible. So today I am here before you putting forward a short question which will be asked in your boards, terminals, and also competitive examinations. It is also have been asked in a slighter way in the entrance examinations also. So the point which is coming is defining the temperature coefficient of resistance. Temperature, you know, the measure of heat or cold, that is temperature. Coefficient, what is coefficient? When we write a thing, no, a variable x, then when we write 3x, then 3 is that coefficient. So here a coefficient is given, alpha. This is alpha, Greek letter. Temperature coefficient of resistance. That means a temperature related, a constant value, a coefficient is there, a value which is related to resistance. Okay, the same thing in the equation over here. When we look at this alpha is equal to a change in resistance is going over. The change after some time, the bigger resistance minus lower resistance at 0 degrees Celsius and at a temperature. Here also a temperature and multiplied by the resistance at 0 degrees Celsius. When we put RT minus R0 over here and just take R0T over here, then RT minus R0 is equal to alpha R0T. Then this becomes the coefficient of R0T, no? That's the essence of which is written over here. So the coefficient of R0T is this temperature coefficient of resistance. Coefficient is somewhat related to constant also. A constant regarding which is related to a certain material. A material, metal, different metals have different temperature coefficient of resistance. That means the resistance will increase with respect to temperature according to different metals, different values are there. So, which is written over here, metals alpha is positive. That means resistances increases. Okay, that means metals, when we raise the temperature, no, this temperature coefficient resistance increases. That is positive value. But in the case of semiconductors, no, this will become negative. That means this, no, will become a lower value. This become a higher value. That means this minus sign will prevail. That means semiconductor, when we give a temperature, no, the resistances decreases. That means the free electrons, what all holes or free electrons are there, that will get higher mobility, higher freedom. That's the essence. So there are certain metals, nichrome and manganese, you must study well. That means these nichrome and manganese are used for making standard resistances. That means they are having low resistance value, low temperature coefficient of resistance value. This is the range, 1.7 into 10 raised to minus 7 degrees Celsius per degree Celsius. Per degree Celsius, that means 1.7 10 raised to minus 7. That's the value. With respect to every degree Celsius, this is the increment. This small value is the increment with respect to every rise in degree Celsius. This is the meaning of this. What all, if you understand it very well also, if it is asked in the exam, now you must repeat it, by heart it, try to know the structure of what all which I am teaching you. Just repeat it, write it well, and practice. So, defining the temperature coefficient of resistance, temperature coefficient of resistance alpha is increase in resistance per unit resistance at 0 degrees Celsius per unit rise in temperature. Okay, when I am teaching you, I will make it that much possible that you will never forget. The essence is increase in resistance per rise in temperature. You know that now. But it is also related to per unit resistance at 0 degrees Celsius. That's the which you have to put in between. Increase in resistance per unit rise in temperature. That means you must write again increase in temperature, increase in resistance per unit resistance at 0 degrees Celsius per unit rise in temperature. There is a resistance at 0 degrees Celsius, no? Just include that in between. Increase in resistance per unit resistance at 0 degrees Celsius per unit rise in temperature. This, no, which I am putting forward over here, the sentence which is written, alpha again I am writing, increase in resistance per unit resistance at 0 degrees Celsius into unit rise in temperature. Okay, increase in resistance per unit resistance at 0 degrees Celsius per unit rise in temperature. That's the essence. So we will come back to a main equation which is written over here. This you understand now, a change in resistance per temperature rise per unit rise in resistance per unit resistance at 0 degrees Celsius. This is the thing. Okay, per unit resistance at 0 degrees Celsius, this is the unit rise in temperature. Increase in resistance is this. Here, we are incorporating two temperatures also. That means now, there is no unit resistance. There is, if you are given a first resistance at a certain temperature, that is a resistance R1 at a temperature T1 of a material, then a resistance R2 which is at the temperature T2. Then another equation should be written. No, there is only a temperature at 0 degrees Celsius. No, we should write a temperature which is similar to this. So RT1 minus RT2. This is written over here. That is R2 minus R1. Similar to this, I am writing. Replacing the whole thing. R0 with respect to another resistance. Okay, R1 minus R2, which is written over here, and then a whole complexity comes over here. You must understand this. The thing is that R1 T2, that means the change in temperature T2, no? R1 T2 minus R2 T1. The explanations are given in the text. If you have any doubt, call me. The thing is that just understand this equation so that it will be useful in solving problems regarding when it is given. Find the temperature coefficient of resistance when a resistance at one temperature and another resistor at one temperature is given. It will be positive in the case of metal and it will be negative in the case of semiconductors. Okay, can we go to the variables? The R2 is the higher resistance. Okay, increase in resistance. In the case of metals, the R2 will be a higher resistance. R1 will be at a base measure low resistance. And T2 is the increased temperature and T1 is the low temperature. But T1 is low, T2 is high, R2 is high, R1 is low. High, low, high, low. That's it. So we can troubleshoot a question which is frequently asked in the exams. Even in CBSE exams, it is asked by just changing all these values of temperature resistances. So the question goes like this. At 27 degrees Celsius, the resistance of a resistor is 83 ohm. Okay, 83 ohm. At 27 degrees Celsius, at room temperature, resistance of a resistor is 83 ohm. Then what is the temperature of the resistor if the resistance is found to be 100 ohm? If this resistance is increased, no, then what will be the encountered temperature? Okay. And the temperature coefficient, the rate at which the resistance increases is this. That means alpha is the temperature coefficient resistance is this way. Per degree Celsius rise in temperature, the resistance will increase this much. Okay. So we only have the aid of the equation, this, the main equation. Okay. Understanding it very well, we will say at room temperature, 83 ohm is the resistance. At how much degree Celsius you want to increase so that this 100 ohm is found in that same resistor. So that you must increase how much degree Celsius temperature so that this 100 ohm will be the resistance of that material, same metal material. So putting this whole alpha value, that means which is given here now, that certain material have a certain alpha value, temperature coefficient resistance value, which is written over here. Then which is written over here. Here R2, in the term of R2, the increased resistance, what is it? 100 ohm is the increased resistance, which is after a given temperature, no, 100 ohm is the resistance of that resistance of that material. What is 83? 83 is the first encountered resistance, R1, the low resistance. Okay, divided by R1 is the low resistance, 83. T2, we do not know, no. What is the temperature which is increased so that you get 100 ohm resistance? So T2 we do not know. Minus R2 is what? The resistance number, the higher resistance R2, 100 into T1. What is the first temperature? What is it? 27 degrees Celsius. 27 degrees Celsius is written over here. Is it complete? Then we want to solve out for what? T2. T2 we want to find out. So just look at this. I am, for the simplicity of solving this problem, no, I am putting this 10 raised to minus 4 in a form of like this. 1.7 into 10 raised to minus 4 is written over here. Then I will just write 1.7 is written like 17 by 10. No, 17 by 10 we can write it. That 17 by 10 is 1.7. That itself can be written 17 into 10 raised to minus 1. That is 17 by 10 is written like this now. 70 into 10 raised to minus 1 into the 10 raised to minus 4 written over here, isn't it? So by the theory of indices, you know, the powers 10 raised to minus 1 and 10 raised to minus 4, 10 raised to minus 5. 17 into 10 raised to minus 5 is the whole thing here. So this alpha value can be written over here. 70 into 10 raised to minus 5 is equal to 100 minus 83, 17. 83 T2 minus 127. 2700. Okay, simplifying this equation. But again, no, this 17 and 17 get cancelled. Then 10 raised to minus 5, no, I can take the whole thing to the denominator side and this whole thing 83 T2 minus 2700 to the left hand side, which is written over here. This, the next step is this. Okay. This 10 raised to minus 5, which is getting into the denominator position now, 1 by 10 raised to minus 5 is written also like 10 raised to minus 5. Okay, theory of indices. So 83 T2 minus 2700 is equal to 10 raised to minus 5. Then this minus 2700. Now when it is going to the right hand side, now then this 1 lakh, which is called 10 raised to 5, now this 1 lakh plus 2700 is written over here. That is 83 T2 is equal to 1 lakh plus 2700. That is 83 T2 is equal to 1 lakh 2700. T2 is equal to this 83 into 83, T2 into 83, that will become, when it is go to the other side, 1 lakh 2700 divided by 83, which is written over here. When we do it, you will get the value 1237.3494 degrees Celsius. 1237.3494 degrees Celsius. When we again discussing the thing now, at 27 degrees Celsius, 83 ohm is the resistance. At 1237, that is 1237 degrees Celsius only, this 100 ohm is getting. That means a small change in resistance occurs with the increase in temperature at the rate of this. This is the rate of change of resistance with respect to unit resistance at 0 degrees Celsius per unit rise in temperature. Understood? So this is the rate of change of resistance with respect to temperature per unit resistance at 0 degrees Celsius, and this is the lower temperature. At that temperature, resistance 83 ohm. This is the higher temperature, and at that temperature, the higher resistance is 100 ohm. Is it problem is complete? No, just work out all this so that you will get familiar. If it is this, if the values are changed, interchanged in this examinations, no, it is given. You can do it very well. The second question we are encountering is a competitive type, objective type, entrance oriented also. The thing is, whatever I am teaching you, I am taking the creamy thing from the syllabus. The same the union set of CBSE, ICSE, and also board examinations also. And the state syllabus also tougher questions are asked. That is also included. That level is also included in the CBSE. So it will profit you very much. What all videos I am putting forward, it will only just furnish, it will polish your basic fundamentals concepts. So be happy, cool, understand it very well. The thing is, a uniform wire of resistance 40 ohm. The question is given a uniform wire. No, this is the uniform wire. That means uniform, a resistance wire having a uniform resistance over unit length. A uniform wire of resistance 40 ohm is bent into the form of a square. Okay, this is thing now. This is bent like this into the form of a square. What is the effective resistance between any two diagonally opposite corners of the square? What is the effective resistance? Look at this figure. When it is made like this now, this is the diagonally opposite points. We can try diagonal like this, but this point is which is said in the question. So every square has equal side equal. Now in every square, sides are equal. So over the whole thing, it is 40 ohm. Then each side is uniform, is having uniform resistance. So 10 is the centimeter, then 10 ohm. Okay. What all is the length, which is divided into 4. Then what all is the whole resistance is also divided into 4 segments. So this when it is shown on the figure, this square has 4 sides and the resistance as a whole is divided into 4. That means 10 ohm is over here, then 10 ohm is over here. Here also the next way. The current is coming over here, 10 ohm is encountered, 10 ohm is encountered. That is the meaning of the uniform wire resistance. That the essence is each the unit amount of resistance per unit amount of length. So this 40 ohm, when it is taken in the shape of a square, each side will put forward a 10 ohm resistance, which is over the which is given in the figure. Look at this. Is this similarizes this, which we already know? Same as this now. That means 10 ohm is in series is 10 ohm. When the resistance are in series, no, it is just we add now 10 ohm, which is when you look into the text now, a resistance when it is in series, just add 10 ohm plus 10 ohm, 20 ohm. Here also 10 ohm is series in series with 10 ohm, then it is 20 ohm, same as now. So this is elucidated over here. Okay, making it simple. Then these two things now, this 20 ohm and this 20 ohm are in parallel now. So that effective resistance is 1 by R effective is equal to parallel connection, then addition of reciprocals 1 by 20 plus 1 by 20, which is written over here. That means denominator is same, 2 by 20, that is 1 by 10. Cutting off by 2, that is 2 by 20 is equal to 1 by 10. Then R effective is equal to taking the reciprocal of this. That means 1 by 10 will turn to 10 by 1. That is R effective is equal to 10 ohm. That means the effective resistance of the whole, the circuit is, the whole resistance mesh is, the whole resistance thing is 10 ohm. This answer is complete. So I will put forward many questions like this so that you will get very much familiar how you want to solve all this. So next is question number 3. What all I am teaching you, it will aid you in the competitive examinations. That's the essence of my videos. Question number 3. The thing is, here is a figure is given. In a figure, a line is given, P line and a Q line, and y-axis which is related to the voltage, and x-axis which is related to the current, isn't it? So in this figure it is asked the VI graph for a parallel and series combination of two resistors are given. The voltage current graph for parallel and series combination of two resistors are given. Okay, two resistors are there, and that two resistors are in series or parallel connection. Identify the series and parallel combination. Identifying which is series and which is parallel, choose it. When we get a finite number, no, not decimal, not fraction, the series, the resistances are just, you will get a whole number value. That means when we get an integral value of a resistance, no, if in the previous question also, when we take this, when it is in series, no, 10 plus 10, 20. When these are in parallel, this when when 20 and this 20, if they are in series, now we will just get 40 ohm, isn't it? By practice, 20 plus 20. If these two are in series, just add this. That is 40 ohm is the total in series connection. If these are in parallel, now we will calculate 10 ohm is the 40 and 10. That means if it is parallel, then it will get a lesser value. When it is in series, it will get 40. That is a higher value. That's the essence. But we will study it far better. The thing is that R always increases with series combination. Understand it very well. If we look at this graph now, what role which is given over here, y and x relation. That means now V by I, V is equal to IR is the equation now. You already know V is equal to IR. Then we will put forward V, this I over here is getting to denominator side. That is V by I. In here, what is V? Y. Is it now here? In here, I, this is X. That means this is a slope, you know. In the earlier mathematics, we have learned y is equal to mx plus c. That is the line equation. Now, here c, what is c? The y-intercept. How? It is in the origin. It is cutting in the origin. So, c is not taken. That is the y-intercept. Okay, we can leave it. Just what is slope? That means whatever slope we have now, y change if it is higher, then that means the resistance is higher. That means the change in y over here is greater or here. This p, the y value with respect to x value is, that means the difficulty to climb. Look at this. When we say in a common man's language, the difficulty to climb this or this, that means the change in the height with respect to the base, which is higher. This p, no, that means a certain amount. This, if you move this much, then it will go this much. But in the case of this, you know, there is a slight, the slant is less. So the slant or the difficulty to climb or the inclination, all which is higher now in the case of V by I, which is having the higher resistance. That's the essence. So R in series is having the slope higher than the R in parallel, which is the slope of Y by X. Okay. So in the VI graph, the slope, what is it? This is somewhat good slant. We can climb it easier, but this, no, this is somewhat difficult for climbing. That thing is having higher resistance. The difficult to climb graph is having higher resistance. That's the essence, which is written over here. So inclination, upward slant, difficulty to climb, everything which is coming, that is having the higher resistance with regarding this graph. So in case of Q, no, the slope is less. That means if it is asked which is having the lesser resistance, which is having the lower slope, that means which is easy to climb. This is the thing. We can climb it very easier. This is the lower resistance, but which is very difficult to climb now. We want to be a mountaineer to climb all. This is the bigger resistance. That's the essence of what raw. Study it very well, understand it very well. If you have any difficulty in the NCERT text exercise questions and also the text part, call me. Be cool, be happy. I'll be there for you. Please like, share, subscribe my channel. Let it be a subject for your group discussions with your friends. Bye. Love you all, my viewers.